Building a roof structure begins not with wood, but with the critical interface between masonry and timber. This is the Mauerlat phase. He rolls out strips of white foam insulation along the top of the aerated concrete walls. This layer acts as a vital capillary break, preventing ground moisture drawn up through the concrete from rotting the wood over time. Once the barrier is set, the heavy baseboards are positioned over preset threaded rods. The alignment must be perfect. He bores vertical holes to match the anchors, laying the groundwork for the entire roof load. A rubber mallet forces the timber down over the steel threads, seating it flush against the masonry. The Mauerlat essentially anchors the roof against wind uplift, transferring lateral and downward forces evenly into the walls below. He grinds off the excess rod to keep the top surface clear for the rafters. A socket wrench locks it all down. The foundation of the frame is secure. With the perimeter anchored, horizontal crossbeams bridge the span. These interior supports create a grid that will eventually carry the ceiling joists and distribute the weight of the massive roof overhead. Working across the open walls, he measures and fits each length of timber. Wood naturally warps and crowns, so each beam is inspected to ensure the high side faces up. Over time, gravity and the weight of the roofing materials will naturally compress the crown, flattening the structure, rather than causing a sag. Maneuvering structural timber requires leverage, balance, and an extra set of hands. These heavy lengths of pine form the primary load-bearing network. Proper placement now guarantees the roof geometry won't distort under the immense pressure of high winds or heavy snow loads. Simple butt joints are rarely strong enough in heavy framing. Using a miter saw, he cuts precise notches into the timber, creating an interlocking connection known as a lap joint. When beams are married this way and secured with heavy bolts, their shear strength multiplies dramatically. The joint resists twisting and pulling far better than traditional fasteners alone ever could. The structural integrity of the roof relies entirely on these tight tolerances. Precision here prevents catastrophic shifting later. The vertical framing phase begins. Rafters are pitched at a specific angle, calculated to shed water rapidly while maximizing the internal attic space. Driving long steel nails through the rafter base ties the angled wood directly to the Mauerlat. This mechanical connection must be completely rigid to withstand uplift. Every strike reinforces the skeleton of the house. A taut string line acts as a flawless, weightless guide across the span. Even the straightest boards can vary by a few millimeters, but the string ensures the peaks of the rafters form a perfectly flat plane. Any deviation here would telegraph through to the final roof surface, causing visible dips in the metal. Once the alignment is verified, he brings up lighter lumber. These 25 by 100 millimeter planks will form the battens. They run perpendicular to the rafters, locking the entire array into a solid, unified web. The spacing of these battens is critical, as they provide the direct fastening points for the outer tiles. Vertical posts are introduced to support the central ridge. A power drill drives structural screws deep into the grain, offering superior holding power over nails because the threads resist pullout as the wood naturally expands and contracts. He marks and cuts a bird's mouth joint, a triangular notch that allows the rafter to sit flat on the supporting post. This small cut dramatically increases the bearing surface, transferring the downward load through the vertical column instead of relying solely on the shear strength of the fasteners. The geometry handles the heavy lifting. A chainsaw is traditionally considered a rough clearing tool, but in the hands of an experienced framer, it cuts structural joints with surprising speed. Working with thick timber at height often requires adapting heavy forestry equipment for residential carpentry. Together, the builders muscle a heavy ridge beam into the cradles they just carved. This central spine will dictate the pitch of the entire structure. The sheer mass of the timber makes adjustments difficult, demanding exact communication and careful footing across the open wooden grid. Trimming the rafter tails creates a uniform overhang, essential for protecting the exterior walls from rain runoff. The blade slices through the excess wood, establishing the final eaves line. Hand tools take over for the finer adjustments near the peak. Securing these apex connections requires heavy torque, driving the screws until the wood fibers compress tight. Every joint must lock together to prevent the roof from racking under severe wind loads. Custom metal brackets are fabricated on site to reinforce critical junctions. An angle grinder shapes the steel to fit the specific angles of the wood frame. A heavy hammer and a pry bar help coax stubborn timber into perfect alignment. Wood that has sat in the sun can warp, so mechanical leverage is often required to pull the boards flush before fastening. The long horizontal beams tie the separate rafter bays together, completing the structural skeleton. The final element of the perimeter framing is the fascia board, running horizontally along the lower edge of the roof line. This long, continuous beam caps the exposed rafter tails, providing a solid, flat mounting surface for the future gutter system. Working from tall ladders requires constant, careful repositioning, but it allows the builders to sight down the edge, ensuring the visual line runs straight. This fascia also serves to close off the eaves, preparing the space to seal out moisture and drafts. The framing phase is complete. After rolling out a breathable waterproof membrane and securing the final battens, the exterior armor arrives. He carries long, dark metal roof panels toward the house. These large corrugated sheets are engineered to be lightweight yet incredibly rigid, mimicking the look of classic clay tiles without the crushing weight. Handling panels this large requires patience, as a single gust of wind can turn the metal sheet into a dangerous sail. A wooden ramp eases the awkward process of lifting the cumbersome steel to the roofline. Once aloft, the true challenge begins. Alignment. The edge of the very first panel dictates the trajectory for the entire roof. He aligns the bottom edge exactly with a taut white string line. If this initial sheet is off by even a fraction of a degree, the error will compound with every subsequent panel, resulting in a jagged, uneven overhang. Accuracy here dictates the final aesthetic. Specialized roofing screws with rubber gaskets lock the metal to the wooden battens. As the screw tightens, the rubber compresses, creating a permanent, watertight seal around the puncture. Panel by panel, the dark gray expanse grows, sealing the vulnerable wood beneath. Walking on a metal roof requires specific technique. Stepping only in the valleys of the corrugation directly over the supporting battens to avoid denting the profile. The interlocking design of the sheets prevents water from creeping upward through capillary action during heavy storms. Seen close up, the uniform texture and precisely driven screws represent the culmination of weeks of hidden structural work. The building is now officially dried in. Raw metal edges are highly susceptible to wind-driven rain and gradual corrosion. To protect the gable ends, they install custom-folded dark metal trim, known as a rake edge. This flashing covers the joint where the roofing material meets the fascia board, directing water safely away from the wood. It also serves an aerodynamic purpose, pinning the edges of the large panels down so high wind cannot catch underneath and peel the roof backward. Silicone sealant bridges the tiny gaps in the metal joints, accommodating temperature fluctuations without cracking. Heavy steel brackets are mounted low on the eaves to catch the eventual rush of water. Next, finished timber is brought up to enclose the open gable end. This final boarding protects the attic space from weather and pests, transforming the raw structural framing into a polished architectural feature. The dark trim against the light wood creates a striking, resilient border. Managing water runoff is crucial for the longevity of any foundation. Without proper drainage, rain falling from this height would quickly erode the sandy soil and potentially undermine the block wall. He works his way down, driving brackets into the masonry to anchor the vertical downspout. Each segment is tapped carefully into place, ensuring the slip joints face downward so water flows seamlessly without leaking behind the seams. While the exterior awaited its final roofing components, work pushed forward internally, insulating the attic, running plumbing, and framing partitions. In construction, delays in one material supply simply redirect the labor to another hidden system. The house matures from the inside out. Now the final rainwater path is secured, steering moisture safely away from the footprint. At the very top, the peak of the roof remains an open seam. A dark metal ridge cap is pressed over the apex, bridging the gap between the two sloped planes. This cap must be perfectly centered and screwed directly into the highest battens. He works his way down the line, securing the final pieces of trim with a cordless drill. The repetitive drive of the screws signals the end of the major exterior assembly. A final inspection ensures no fasteners were missed and all seams sit flush. What began as a pile of raw lumber and open block is now a defensible, weather-tight shell. The contrasting lines of dark trim against the white masonry provide a crisp, modern exterior. Yet the true value of the build lies in its hidden mechanics. The capillary breaks, the structural lap joints, and the heavy timber cross-bracing that no one will ever see again. Standing alone in the open field, the house is fully prepared to endure the changing seasons. A roof is the primary shield of any home. This steel canopy guarantees the fragile interior progress will remain dry, warm, and untouched by the elements. Every board, bolt, and metal panel carries a cost, both in materials and immense physical labor. But building it by hand strips away the markup, turning sweat equity into a permanent asset. In the end, structure and landscape operate as one cohesive system, a quiet testament to careful engineering.